Okay, so in this video, we're quickly going to review the multi-criteria decision-making rules. And we'll start by looking at an example of buying a notebook computer. So let's say you have four different options to choose from, model A, B, C, and D. And notice that we have picked four features. So RAM, hard drive, screen, and processor speed. We also have price, which is also a consideration. So let's try the different rules. The first rule that we're going to try are non-compensatory rule. And just to remind you, a non-compensatory rule is where you have an attribute um, that cannot be traded with something else. So let's say if in a non-compensatory rule, you want to buy something that has a webcam built into it, and you find a lot of computers with all the other features, but they don't have the webcam. Since it's a non-compensatory rule, so the absence of webcam cannot compensate for the other features, and you would not consider those computers. You only look at the ones which have a webcam. In a compensatory rule, you say that a feature that's important to you can be traded. For instance, an example would be that you're looking for a lightweight computer, and um, there you would want a DVD drive built in, but you're open and you're saying, even if I will, if a model is really amazing and features of, I mean, it's a very fast processor, hard drive is very good, then I am willing to forego getting the DB drive built in. Okay, so that's a compensatory. So you're willing to trade off something that you really wanted with something else which you think might be of good value to you. So let's start by looking at these rules. So let's start with the non-compensatory rule, and we'll start with something called screening. With screening, what you're doing is you set some attribute. So we'll do conjunctive screening. Conjunctive basically means and clause. So every condition that you specify has to be met for this alternate to be considered. So in this case, let's say that the first condition that we set for ourselves is that we don't want to spend more than 700 dollars. So if we don't want to spend more than $700, that would get rid of what? That would get rid of model um, B, because it's more than $700, so it gets gone. And it's also going to remove model D from any consideration. And our next rule is that we want something that should be at least 14 inches. So out of the available options, C is 12 inches, so that's eliminated. And you're left with one option only, and that is model A. So that would be your choice. So that is a conjunctive rule. So all the conditions that you set have to be met. That's a conjunctive rule. Okay, let's go next and look at the disjunctive rule. In a disjunctive rule, what would happen is um, you have to set minimum criteria, but in this case, you don't expect all alternates to meet all criteria, but they should meet at least one of your criteria. So it's an or, okay? So you're saying, okay, I'm interested in something that is really fast. So what is really fast is 1.9 gigahertz. So we'll say, okay, so that, put a check mark over there. So that's one of the things that you can look at. You want something that has, um, at least 100 GB of hard drive. So we have two options over here. So um, that would be this one, A and B. And let's say you want to consider something that's 15 or better. So again, if you look at that, you have so that's, these two are okay. Now, if you look at these options, so that means in our final consideration, A and B can be considered because they meet at least one of our criteria. C and D are eliminated. So you would choose between A and B. Now, if you were purely choosing based on pricing, then you would pick model A. If you're choosing based on performance, then you would end up choosing model B in this case. Okay. So next we look at selection decision-making technique where we do selection by elimination. Selection by elimination is that you specify a feature, and based on that feature you narrow the choice down, and then specify the next feature and narrow the choice down further, so on and so forth, till you get to a single single option that you can pick. So let's say I start by saying that I'm only looking at computers that need to be at least 1.8 gigahertz of faster processors. So that would get rid of this one, C and D. They're no longer considered. And I'm only interested in computers that are at least 100 GB or more hard drive. So that would again, so we already eliminated C and D. So these computers don't meet this condition either. So we still have A and B. And now if you say I want a computer that's more than 15 inches, so that would eliminate this, and finally you're left with only one option, which is model A. So what we've done is we started with specifying a feature, use that feature to eliminate some of the choices, pick another feature, eliminate some more choices, so on and so forth, till you get to the one that you really want. Okay, so that was elimination. The next one that we're going to look at is called lexicographic selection. In a lexicographic selection, what you're doing is pretty much the same thing, but you start off by doing a quick ranking. So let's say we do a ranking over here. So the cheapest is 5, so we'll give that a rank of 1. So that's number 2. That B is number 3, and 4 is D. In terms of processor speed, number 1 would be model B, number 2 would be model A, and number 3 would be model D, and number 4 would be model C. In terms of rank, RAM, so number 1 is C, and everyone else is ranked second. So there we go. And for hard drive, A and B are 1, and D will be number 2, and C will be number 3. And finally, for the screen size, A is 1, B is second, D is third, and C is fourth. Now we look at the scores and we find out that model A is ranked number 1 on 2 aspects, B is ranked number 1 on 2 aspects, C is also ranked 1 on 2 aspects. So we can eliminate D because D is not okay. And then we look at the scores again, and you can see that overall in terms score turns out that A has the best score because it is second on 3 aspects and first on 2 aspects, compared to B, which is first on 2 and second on 2 and third on 1 aspect. So we can say this seems to be the most well-balanced model. In more sophisticated application of this rule, you might actually put some weights. So instead of just adding up the ranks, you might say that I'll put a higher weight on screen or a higher weight on processor speed. Okay. Okay. On a compensatory rule, you basically now use a weighted method, because what you're saying is that so you have preference for features, but these preferences are based on, so let's say they can be traded, so it'll be the same ranking, and you would then get the scores for the different models and pick the one with the best score. We did for the linear, we've already done AHP. So for linear, you instead of assigning um, weightages arbitrarily, you assign weights based on the pairwise calculation that we've done in the earlier video. So that's a quick